Hello everyone, my name is Rinehart, and today I'll be presenting our research title called Classifying Instances of DNS-based Internet Censorship using Machine Learning Models Trained on Reachability Data. Now, this presentation gives a brief overview of the problem we're currently working on, our data and methodology, and the progress we made so far. Now, just to let you know, the full result for this presentation will be updated towards the end of the semester for our final presentation. So this slide here is just basically a table of contents. Just going to go over topics we're going to talk about, ranging from problem statement, research objectives, background, data, methodology, and then towards the end, we'll go over progress and future steps. Basically, that's stuff that we'll go over that we'll work on before we finish the semester, and then the closing portion we'll go over as well. Okay, so for problem statement, now around the world, governments and organizations are increasingly restricted access to information online. One of the ways it's happening is through DNS-based censorship, where the access to the website is blocked at the network level. This means that current detection systems can not only identify censorship after it's already happened, but also it means that users lost access to the content they're trying to get or use at the moment. Now, the goal of our research is to use machine learning to identify when censorship is occurring or even detect it even before it spreads. Okay. So now for research objectives, our main objective is to develop a supervised machine learning framework that can accurately detect DNS-based censorship. Now, in order to do this, we're going to use this data set that we found called IC Labs Reachability Dataset. Now, this includes global measurement of internet connectivity and censorship. So for this research, we used three different types of algorithms, which include random forest, like GBM, and logistic regression. Now, these are used to compare the classification of the performance. Based on this, the broader goal is to build a foundation of an early warning tool that can help detect digital freedom and access to information. Background. So, for those that don't know, the domain name system is what DNS stands for. So think of it this way, it acts like an internet phone book. It can translate domain names like google.com into numerical IP addresses. I think that's the best way I could put it for those that are not familiar with the terminology. Now, because a DNS controls how we reach websites, it's also a prime target for censorship, unfortunately. Governments can manipulate or block DNS responses to direct users or prevent access entirely. Now, what this means is that this type of DNS-based censorship can look similar to ordinary outages that we've been seeing at times, in the news, but it also makes it difficult to detect automatically, to be honest. Our work builds different on these studies that typically use censorship planet, but what we do different is we're going to use real-time detection with the IC Lab dataset, where we're going to train the machine learning models to identify censorship events as they occur. Okay, so onto the data section. So as I mentioned just now, that we are using the IC Lab dataset, which collects internet reachability measurements around the world. This includes, certain key variables, include DSA tampering, indicators, domain names, and so forth. And you can look over it under the key variable section, where it's got a list of variables that we're using. And of course, since we're using machine learning, we decided to make sure censor was give us ones and zeros in order for it to read. Now, these comparisons allow the model to learn which patterns and DSA data are associated with censorship activity. Okay, so onto methodology. Now, our workflow starts with data cleaning, which removing incomplete rows and non-DSA related data. Then we perform, feature engineering, which was important prior to, run through the machine learning pipeline, which that included encoding booleans and categorical variables and calculated features such as IP diversity and DSO match ratios. Then we decided to train the three supervised models: random forest like GBM and logistic regression using scikit-learning. Then finally, we evaluate the performance using standard metrics like accuracy, F1 score, and so forth, which are going to be used to determine which model best classifies the censorship instance. So now to progress and futures. So far, we've completed our data sourcing, cleaning, and future engineers for the pipeline. And now we're at this part where we're starting to test our first models. The next step will involve tuning the model's parameter, visualizing the results, and then, of course, analyzing how performance varies across different countries and censorship types. We'll then present the final results, include performance comparisons and visualization, and we should have this all done completed right before towards the end of the semester where we conduct our final presentation. Now, thank you for taking your time to watch this video. I'll be sure to get on Ed discussion to see if any of you guys have any comments, questions, concerns. Again, thank you for taking your time out, and I hope you all enjoy the rest of your week.